I have a few questions. You
Mhm.
can hear me?
Yeah.
I guess it's two questions. I'll ask it one at a time. The first one is just why do you say the language models struggle with German more than English? Because your results already show English has more surprisal, and we do other things as well with language model trying to predict acceptability of languages, and found that German is much easier to predict acceptability using language model compared to English.
So this example is what you're referring to, right? This would really just be one individual sentence. So the point of this is to say individual sentences might really be different, right? Which is why we want to get as many sentences as possible to average over. And the results we haven't gotten to yet. So that's why this teaser in the beginning is like, we are going to see that it's going to be a lot.
Okay, we'll leave it, we'll wait until the results and we can come back and look at it. The second is just a clarification question. You talk about using open vocabulary to measure surprisal. Just a clarification, are you having one open vocabulary for each language?
Yes.
Or the reason why I feel it's potentially a bit of problematic, because if you have, just to illustrate why it might be problematic, let's say English, you only have 10,000 subword or words in your open vocabulary, and another language has 100,000, right? Then the surprisal won't actually be comparable because the vocab size is just very different.
So we should be, so this is going to a few important points. So maybe I should go back to that slide. It's kind of touching on the two things that I said are really important to keep in mind. And that's that we need to be open vocabulary. So if you're saying subwords, I'm assuming that you are already open vocabulary. You're not having any unks in there anymore, right?
Yeah, I mean, it will be character or whatever bytes.
Sure, we can do character level. That's perfectly fine. The second is we cannot look at the perplexity, the information content per word or per character, because that would make things incomparable, right? In this case, Czech would look harder than German just because Czech has fewer letters in this word. And so that's why we just take the sum of all the things, the entirety of the sentence.
Oh, you don't actually normalize it.
It doesn't matter how we segment. It doesn't matter whether we did characters or subwords or some fancy two-level model. As long as we are open vocab and get the probability or the negative log likelihood for the entire sentence at a time, it doesn't matter how we model it.
One query, I'm not saying this is wrong or anything, but when you're computing the log probability, right, because you still have to compute the probability for every token or subword or whatever in your sentence, right? The fact that you have a much larger vocabulary would generally mean, there is going to be lower probability, right? Wouldn't that still going to affect you even though you're still taking the sum of log prob?
The thing is, if we have a language that has a very large inventory, and that's like maybe a result of morphology, it means that we are going to need less particles or stuff like that. And so our sentences are also going to be shorter. So while the individual unit is harder to predict, there will be fewer of these units to predict. And so the hypothesis here is that really the information might be kind of the same in all the languages. And so some languages do this by having very hard, but very few units. And some do this by having very easy units, but very many of them. So that's the thing there. And we will, in fact, compare against some of these things for correlations in the results. Yeah, great questions. Thanks.
Hi, can I ask a question?
Yeah.
So let me just move the window here. So this might be a bit of a nonsense question, but I'm going to ask anyway. Apologies if that's the case. Just destroy my argument, please. You evaluate your models using the log likelihood, right? And I assume you also training your models using maximum likelihood estimate, right?
Yeah, regularized likelihood.
Yeah. So I mean, so in your case, when you call it difficulty, it's not just the difficulty of language models in general, but difficulty of language models trained through maximum likelihood estimate, right?
Right.
Okay.
Right.
So
this is saying the difficulties for this particular language model. And when I say this particular language model, I mean both the architecture, the training regime, the hyperparameters, and so on. That's really all we can say, right? Yeah. When we started this, I remember the collaborator I worked with on this for like the previous paper came to me and was like, hey, with this, we can prove that English is inherently easier than German. And I was like, wait a second there, aren't we talking about language models? So it's really all we can say. We don't know if it's language models struggling with the language, or if there's something in the data that is intrinsically more complicated. So we have that uncertainty. I believe that I don't really see why the data should be all the different. I believe what we're seeing is models coping differently well with different languages, but that's something that's going to be hard to untangle.
Yeah, I mean, I appreciate, no pun intended, but I appreciate the difficulty of defining difficulty. Because I was just thinking as an alternative, you could have hypothetically a language model which is Bayesian and use a zip prior over the frequencies, and then you train over that, and that's your language model. Then it's not going to be a MLE estimate anymore. It's going to be if it's empirical base, it would be a map. You would train it by a map, and then now even using the log likelihood might not be as a metric for this kind of language model might give you completely different results. And
I don't think, like, I'm not that worried about training, because, like, I mean, what we're doing is never maximum likelihood, right? It's always a regularized version. It's always some way, some way. We could just call it map inference with some really wacky priors if you think that dropout is actually Bayesian variational something, you know. So it's never really pure MLE anyhow. And I think as long as we have a model that assigns probabilities to sentences, we can score that model with this paradigm. And again, this is true, as you say, only when we say difficulty means difficulty predicting a sentence, surprisal when given that sentence. And you might say there are other things that are more important. It might be more important to generate grammatical utterances rather than to cover the entirety of the space. And so these are things that we're going to get into a lot in the third part of the talk when we talk about translations more.
Okay, thanks.
Yeah. Are there any other questions? Yeah, I have a quick question. So the languages in the Bible that you use, do they all have standardized orthography? Because one thing that I was thinking, like when you have languages that are very under-resourced, like one of the problems you face is that they don't have this standardized orthography.
Right. I honestly don't know. What might make this a little bit less bad is that really for every language, in case of the Bibles, we train on some books of the Bible and test on some other books of the Bible. So assuming that at least orthography is consistent within that Bible, and not like stochastic, that shouldn't be too much of an issue. I'm saying shouldn't because there's a lot more going on here. For example, the Bibles that we use are also tokenized in ways that may be kind of sketchy. So we use the tokenization we're given. We just try to not do anything beyond that, but we are already given data that might not be perfect. That's fair.